All right. I'm going to get us started because I will probably need the entire hour. And a little upfront warning. I'm going to have a bit of code on the slide. I got some feedback that it may not be in the best font because it's black on some darker colors. So if you're in the back, you might have trouble reading it. So the old Jason Turner, you might want to stand up and move a couple rows in. It'll be a little easier to see the slides. I do try to make sure I've highlighted what's important, but be warned, there's a lot of, there are some codes, slides with a lot of code. So I'm going to get started. Thanks, Kevin. Got this. My name's Richard Powell. I've been programming in C++ for over 20 years. I've had the great fortune to work at several great companies over the years, and I've worked in audio software development, audio DSP, and problem solving there. And currently, I architect audio experiences for the Meta Reality Labs products. And I've worked on a number of different things. I love coming to conferences. I've seen a lot of great talks. And today's talk is going to be about declarative programming. I've always thought these talks are great. I like the way the code looks. I like the way it feels. Yeah. It's coming. Don't worry. It's intentional. And so today is going to be a sort of case study in declarative programming. And a lot of times when I've seen these talks, I go, wow, that's really great, but I could never use that in my code. My code can't be made declarative because it's really complicated and it wouldn't fit. But I found with a pet project of mine that I found a bunch of practical techniques that you can use that can make your code, which feels non-declarative, become declarative. And while we're going to be working with GUIs for this talk, this is not a talk on UI and UI development. So we are going to be talking, though, about wxWidgets. There's several UI frameworks out there. Qt is probably the one that most people are familiar with. There's also Juice. There's some other ones. But my experience in the project I was working with, which was called CalChart, the California Marching Band charting program, which I maintain, go Bears, is written in wxWidgets. It's a great C++ framework. It has everything that you would possibly need from a framework. It's got your sort of controllers, your buttons, your sliders, the sort of elements that you would expect to have in a UI program. It's got the ability to make applications, launch frames, do other windows, and it has do and undo systems and sort of all the practical stuff you would need to make a modern application. It abstracts all of the system native fundamentals for that so that you can program in a cross-platform way. Now, I'll say, I am not an expert on wxWidgets. There are people who are far more experienced with it than I am, but I have practical experience with it and with building this larger application that had a lot of complex interactions. But instead of really talking about it, let's actually demonstrate it. We're going to make a little application. This is my little Hello World app. You can find it on GitHub if you wanted to. And all of the code should be there, and we can just kind of play around with it. So I'm going to make a very, very basic application. So what I have here is basically I have my project that consists of a CMake file. And in my CMake file, I have, I'm just very, very bare bones CMake file, make it C++ 20. Find wxWidgets, and it is already been there. I've installed it previously. I'm going to make a Mac bundle. I'm on the Mac, and just a couple of compiler parameters, and I'm going to start with the basic hello world. That actually, this is from the wxWidgets getting started page. And so a thing about a framework is it really influences the way you program. If, I had a coworker, Jeff Lee, years ago when I was like, hey, when I started using this framework, I started coding differently. He's like, yes, your UI framework is really going to control the way you program. If you try to go against some of the framework paradigms, it doesn't quite work. So it's best to sort of lean into their paradigms. And in wxWidget, it's a lot of inheritance and a lot of subclassing, like many common frameworks are. So my application, my app, is going to be derived from the system, the global application class. I'm going to say, hey, I've got a frame, which is my frame. It's derived from that. And this declaration here, or this macro statement does all of the magic underneath the hood of getting your main instantiated, causing the runtime to get launched, all of the sort of complexity there. And my init function gets called, and on it, I am just going to create a new frame. And so if we were to run this application, it's probably going to pop up over on the wrong screen. Yep, let me bring it over here. So here's my app, and it is as exciting as the code portrays it to be. There's nothing here. It's a single frame. In fact, actually, I don't even have really menu buttons or anything to quit. So let's make this a little more interesting. So I'm going to manually exit it that way and check out example 2. Right, so now what I'm going to do is I'm going to add in a bit more functionality into my frame. I'm going to add some member functions. There's this event table in these enums. So this is how wxWidgets connects controllers to function calls. You say this event, this ID, there's some enums that the system has defined, like exit, about, help. And then you have your ones that you can create, and you can cause them to call functionality. And then what I do is inside my frame, I will say I have a new menu system. And it's like, wow, it's just sitting there out by itself. Yes, this is the convention of wxWidgets. A lot of naked news, a lot of things to knit about that, but this is their framework paradigm. And I simply add my elements to my menu system. I can create a little bit of a status bar, and I've got my functions that get called when I invoke them. So let's now try this out. And as you probably expect, now I have some menus, and I can do things with my menus. So hello, and I get a little pop-up, and hello world, great. Let me quit that, and let's add a bit more to this frame here. So with my example 3, what I'm going to do is I'm going to build in more controllers into my, my frame. And you can see I'm going to create some texts and some static text, some text controllers, which are boxes, buttons, the sort of practical controllers you would expect in most dialog boxes. Radio buttons and checkboxes and choices and dialogues and buttons. So then what the example that we do here is we're going to start laying them out. wxWidgets has a dynamic sizing type of system. You can put your controllers in those elements, and as the frames get resized, they will try to figure out the right bounds. So you can lay them out vertically, horizontally, boxed, and you can control the way that they expand or contract or have borders. And this is not uncommon. A lot of UI frameworks have this, where you can have a programmatic way of laying out your controllers and having them resize. And you can ultimately, there's this function called setSizeRandFit. That's a member function of the frame. And that essentially takes that sizer that you've constructed and puts it all together. So it allows it to say, okay, given this sizer and given all of these elements, fit them to that screen. And I may have forgotten to mention, yeah, maybe a detail here. When you construct your controllers, you supply this pointer. That's the parent level frame. That's the one that's going to ultimately manage all the life cycle and be able to know how to connect all the pieces together. So, and then you can add lambdas to buttons. So this right and left buttons are bound to a specific execution. And so if we run this, this looks more like a UI we would expect. And you can see that what we have here is all of the controllers I've created get laid out. I have my radio buttons, my checkboxes, my buttons. They're all sort of laid out in this way. And if I were to click one of the buttons, yes, cool, I get a pressed right button dialog box. Pretty simple overview. And this is actually the I cribbed this from the wxWidgets Hello World example that they start you off with. Let's go back to our slides now. All right. So let's kind of dive in a little bit deeper into what I just went over pretty quickly. So here is my code, and here is the example I had. And as I was pointing out with that controllers section where I'm creating all the controllers, what I have is I sort of declare and these controllers to exist. They're sort of allocated there, and you can see that their names very much correspond to what they are. a wx button is a wx button, a checkbox is a checkbox. You supply them with probably particular names, and it's sort of, you can almost, from the code, see what you would get. It's very reasonable. It makes sense. Now, if we were to scroll down to the layout section. Now, in the layout section, I find this to be a little bit, let's take a look at what we do here. So what we have is the concept of vertical and horizontal sizers. So what I can do with a sizer here is essentially, this one's a vertical one. So each of these elements are now laid out vertically. I have a horizontal sizer for my checkbox, and so those ones are laid out horizontally. Essentially, I have these groups of sizers. My buttons are laid out horizontally. And then what I do is I have a top level sizer, which takes each of those elements and lays them out that way. So it's the way you build up your UIs. I'm like, I want these elements to go this way, I want them to be this way, and you can sort of create more complicated dialog boxes that way. Oftentimes in larger other frameworks, you'll actually lay this out in an XML file. And Qt has sort of a description language where you'll put the layout in somewhere else. But generally, you can, wxWidgets offers this facility for putting your layout in line with the code. Now, what I find about this laying out code is it tends to be fragile. Like, it's pretty easy to temporarily erase a line. And when you do that, you end up with a UI that looks something like this. And so, all of the controllers are there, but what the layout, the sizer and fit, didn't quite know where to put that one element, the radio button. So it just put it straight at the top, just overlaying it on top of everything else, which doesn't really look right, and it doesn't size everything appropriately. Another thing is a lot of times, like, that code's a bit of a word salad. And what if I mistyped sizer detail, and instead of using details, I used, I don't know, the sizer itself, or sizer text, or the wrong one. So I would get all of the elements laid out. It just wouldn't look right. This wouldn't conform to the design I wanted. And you spend some time looking at that and you're going, what did I do wrong? And it's like, and then I'm like hunting, I'm like, oh, sizer, right, sizer text. Very clear from the code what I did wrong. No, not. So to me, this makes the layout code very brittle. It's easy to screw it up. If we compare these two sections of code, it's pretty striking how different they feel. I think the code on the left-hand side is a bit easier to understand. I can really see what it's going to do because it's there in the names. I can tell what I want from the left-hand side. Now on the right-hand side, I'm a little lost. I sort of need a guide to help me what's going on. So what is it about the left-hand side that we find easier to understand? What was that? Practically everything on the left is a declaration. I'm really being more declarative. I'm saying what I want, more so than how I want it. So from Wikipedia, declarative programming is the non-imperative style of programming which programs describe their desired results without explicitly listing out the commands or steps that must be performed. And so I want to call out a great set of talks from Ben Dean, right here in the front row, about declarative programming, style indicators. This talk goes through a lot of them. I'll say, I think what one of the things I took away from the talk was about preferring expressions over statements. And so I'd say the first slide, the slide that was on the left-hand side, was much more full of expressions than statements. Another great talk to check out is Calvin Henney's talk about declarative thinking and declarative practice. And he points out data structures. If you can see what your data structures are, it's easier to see what you're declaring, what the intent of the program is. So keeping those two things in mind, let's talk about these parts of the code, we have more declarative and more imperative sections of code. You can see, like, what I find remarkable is that left-hand side's all about, hey, here are the things I have, and the right-hand side is about laying and adding it, doing something, a procedure. For each of these items, do something. And I'd even say, if you were to replace the word add with something like push back, it suddenly starts, hey, actually, those sizers are almost like data structure-like. Huh. And in fact, actually, we can see that a lot of the code ultimately boils down to this one function here, set sizer and fit. Essentially, I'm taking all of the controllers and all of the layout, and I want to put it into this one function. So this, in effect, this whole thing is itself a data structure. It's just hard to see. So how can we make the layout more declarative? How can we make this data structure emerge? All right. We're going to start with a more simplified example. So this is really a simple example. Little tiny UI. I have 4 controllers. I've got a button for click, a text controller for dog, static text for cat. Done. I'm laying them out vertically, horizontally with the whole top level sizer laying them out vertically. A little easier to understand. It'll fit on one screen. And so what I'm going to do first is I have my part of the code where I am declaring my controllers. These are the items that I'm going to be dealing with, my widgets, if you will. And then I'm going to lay them out. And so this is the part of the code where I lay them out. Now, I am an almost always auto type of programmer, and we can see there's a lot of redundancy with our types. So let's do that first. Let's do a first little cleanup where we'll make everything auto as much as we can. And so now it's really clear. I like to program this way because I like to see my types on the right-hand side of the equal sign as opposed to the left. And it also makes everything lined up really nice. Isn't that cool? And then we don't really need to construct these controllers ahead of time when we use them. Why don't we just put them in place? And so there we go. Makes the code a little more dense, easier to see what we're doing. And we can also start seeing that there's a pattern that's here. So it's emerging. So let's do some refactoring. We see that we have some common steps that we're always doing. We're always taking a sizer, adding a controller to the, constructed with the this pointer. We have some values, like these are sort of values that are they're either return values or static values in the code, but they're values. They're all consistently the same type. And then we have type parameters. And so these are all different types each time. And when I think about refactoring, I like to say, okay, let's take our common code. We're going to make a function. We're going to put the common code there inside the function. When we want a value passed to our function, we take them as parameters. And when we want types taken as a parameter, we take them by template. So let's make a function for this. I'm going to call it create and add, because that's what that function's doing. And so let's construct a create and add function. And so our create and add function, and what our create and add function is doing is it has our common code, so it's going to take all that common elements and execute them. I'm going to take my values as arguments, and I'm going to take my types as templates. That's how you pass a type parameter to a function. Great, so now I can just refactor this as opposed to having these functions here. Let's call them on functions. Okay. Cool, so I've got a bunch of functions here in the program. Now, I'm going to do a bit of a leap of faith here, but what it is you can have functions, but like I can abstract things as a function, but I see what I have here is I have sort of a type and I have state. There's some state that is associated with it that's going to be collected together. And what I'm doing is now these two items are more tightly coupled, if you will. What I could do is I could create a data structure for containing those, and then I could call a function on it. I could maybe put all of this sort of into a class and then have a member function that does the functionality. Makes it a little bit clearer about that it's a data structure. So to illustrate what I'm talking about is, so I have my widget. My widget is going to have some state that gets constructed, and it's going to have a member function, which is going to be my create and add. So this is a bit of a sort of, well, really I kind of unrolled almost this function, if you will, to put stuff over here and then have it apply to this function. Seems weird, but this will be clearer later. And so I can rewrite this now. Instead of a function being called, I have a widget struct that will hold on to what I want to be applied to my create and add function. So now it's actually pretty clear that, hey, this was being a function call, it was constructing a struct and calling its member function. And now I'll note I did make some subtle little differences here, which is this text controller has a different sizer flags than others. This is common in UI frameworks where you're like, hey, I want this one element to move. And what I was trying to illustrate here is oftentimes you'll actually specialize certain objects over others, and that's not uncommon. So and we know how to specialize data structures. If I want a class that's going to behave slightly different than another class, I just have it have different member functions, variables. So I could have, say, a optional sizer flags. So, and our convention could be is if you're supplied one through the create and add function, use it. Otherwise, if I was constructed one, use that one. So we can have that sort of behavioral way. So that way it allows specialization to occur. I see there's a question.
Yeah, I don't have mine. I just want to make sure I'm reading the code right. You are destroying that widget object on each semicolon on each line, right? Like it only lives for that state.
Yes, actually. So the question was, hey, doesn't this mean that the widget object here is only living for the lifespan of that line? And the answer is yes. Yes, it is. The widget itself isn't really doing anything. So struct widget is just holding on to the ID string, optional size flags in this case. But the create and add function is the thing that is constructing my UI. So yes, it's a little odd. You're like, why I'm just putting things into a class just simply to throw it away. I'm putting things into a class so I can call a function on it, which is going to apply further. You'll see why later when we get to a larger sort of data structure.
Sure.
Cool. All right, so like I was saying, I have the ability to specialize different widgets. So I can give some widget flags and some widgets that don't. And so that way I can have this homogeneous calling structure. So every create and add function here looks the same. Text controller for dog can be different because it has, it's been declared with different sizer flags. All right. So we can see that the data structure's kind of emerging here. Let's look a little deeper here and see what we have here. So as we can see here, I have multiple types, and I'm applying the same thing to them. I almost have, I'd say I have a collection here of different types. It would be what I would call a a heterogeneous collection. What do we call a heterogeneous collection in C++? Tuple. You saw this before. Anyway, so it's a tuple. So I have a data structure that's a tuple here that emerges, and I have some functions I want to call on each member of that tuple. How do we call how do we call functions on every item in a tuple?
Template 4.
Template 4, right? No. Template 4 does not exist. I also heard standard apply, and I'm going to go with standard apply. So standard apply, introduce C++11. I find the syntax a little wordy. If you're not using it on a regular basis, you'll like, how do I use this? But CPP reference has a really good reference on how to use it. And so let's try it out. So I'm going to add it to the code. So going back to our example here, I have my, let's make the data structure more apparent that I have a tuple here. So I'm going to say I have my lower widgets tuple, and I'm now going to call standard apply to each member of it. And so that's the way I would call it. So apply that lambda to the lower widgets tuple, and it'll go through and it'll execute each function on that. The flags, those sizer flags, they should probably be more like an argument. Let's pull them out to the capture. So there we go. That looks a little better. It's just refining some code here. So let's refactor this as a standalone function to make it easier to use. So I've got my create and add function here. It's given a tuple of widgets. It's going to add them to the this pointer. It's going to create them with the this pointer and add them to the supplied sizer using the sizer flags. So it would look something more like this. And that's actually a little easier to see that this is a function. You're actually not really seeing my construction and destruction of those widgets. It's more like, oh, this is looking more like a data structure. And we don't have to have the standard tuple here. Why don't we make a helper function which takes a param pack, and then underneath the hood it does the make tuple for me. And so that makes the code a little bit simpler to use. And I think this starts, you know what? The widgets, static section, the widget button, I don't need to have widgets repeated a couple times. We'll use some using declarations, make it easier to see. And now, actually, hey, this is looking a lot more declarative right here. I can say, hey, what am I doing? I'm creating and adding, you create with this, add them to the sizer, and what do I want? Create these things. All right. So, we should be careful about using sort of any function as a widget. I think we were, even in the keynote, it was talking about like that we know what the widget needs to support. Widgets need to support the create and add functionality. They need to be given a parent that they will be created with and a sizer to add them. So let's create a specific constraint for that. Let's create a requires clause as a concept, and we'll say create and addable. Create and addables are things that support that interface of create and add. Okay, cool. And so now I can replace, instead of just using type name, just a generic template, I'm going to use specifically widgets, going to constrain it further. And this gives us the benefit that I can now do static asserts. So as I'm writing functionality, even before I've run any code, I have confidence that whatever I've added supports this. Cool. All right, let's pop the stack a little bit. Let's go back to where we were. I think I see another refactoring opportunity here. So let's do our exercise that we did before. We have our common things that we're doing all the time. We're always creating sizers. I'm creating these horizontal sizers. I'm now calling create and add with all the individual widgets there. So these widgets are my values that I'm passing in. And I have types. I have these specific types that I have, these widgets. They could be all various types. So, and I also think that what I can see here is I have two expressions happening. I have this new box sizer and create and add. I think what I could do is using our same techniques, reduce this to one expression, which is I'm going to use that same struct with member function, and instead of it, it's going to return the sizer in this case. So let's illustrate what I mean with a little bit of code. So I have a sizer struct. Sizer struct is going to be constructed with all that state I want it to hold. So it's going to take an orientation, vertical, horizontal. It's going to take its sizer flags, and it's going to take all of those widgets. It's going to capture those widgets, or copy those widgets in a real implementation. There's probably a lot of forwarding that goes on and a lot of optimizations that could be done. And I'm going to have a create and add function. So what that's going to do is it allows me to rewrite my code like this. So sizer lower is the result of a sizer struct's create and add function to this. All right. So I've gotten rid of those two expressions, but I think what I can do is go a little further, and instead of having two expressions here, two statements, I could probably fold this into one. I could probably take that argument, the top level sizer, and stick it into the create and add function with those sizer flags. So let me manipulate the code again, and let's add those as additional arguments, and then my top level sizer gets called this way. Great, so now I have the single sort of declarative statement, which is I have a sizer, it's horizontal, it has these flags, it's going to take these widgets, and it's going to be added to my frame, to the top level sizer. So, and I think if we can probably go a little further, we can use the convention that we've been following, which is sizer flags. If they're the same as the one that's being added, I can remove it. So there's reduce the redundancy. I could specialize it by a special constructor. But if you don't have any reason to be special, let's just use whatever's been supplied. So we can add that sort of optional concept that we had for the widgets themselves. And we can reduce this by a little bit. And now a look, which is the orientation, is taken as a parameter. It's an enum that really only has two values, and it's like, I guess for defensive program, you would check to make sure I wasn't given a bogus value, so that. But I could probably do that with some typing. So why don't I create some subclasses, H sizer and V sizer, and then I could just write like this. Very cool. For those of you who use Mac-based programming languages, yeah, that's no coincidence that the name is the same. Now, there's something I did with these the sizer object that may not have been noticed. In fact, actually, I kind of did it on purpose to see if anybody did notice. There was a little bit of a subtlety that came in here, but it's a happy little accident. So what it is this function, create and add. So sizer is a thing, an object that takes any number of create and addable functions, things that support the create and addable function that take in the sizer. Well, sizer itself is a create and addable. So widgets are create and addable, but sizer is now create and addable, which actually brings up the interesting thing, which is, before we were static asserting, yes, is button a create and addable? And yes, it is. Well, is horizontal sizer a create and addable? Yes, it is. Is a vertical sizer that has horizontal sizers create and addable? Yes, it is. We've essentially created a tree structure here. It allows us to compose larger UI elements together just with this sort of declaration. So which means, in theory, I can take our sort of simple example and I can compress this into one expression. But there is a bit of a challenge here because top-level sizer is slightly different. Top-level sizer, so we see our create and add function takes in a parent sizer. It needs to be added to somewhere, but top-level sizer doesn't get added to anything. It's the top. So it needs a slightly different function. No problem. We'll just create a specialized function for it, which will look like this. So if I have anything that needs a parent sizer, a place to be placed, it'll have that. And if it doesn't, it'll just be added directly to the parent to create the sizer. Sorry, it'll just be constructed and returned. It won't be added to any parent, which means I can write something that looks like this. So I have my top level sizer, it's a vertical sizer, and inside of it is two horizontal sizers. And each one of those has my buttons or my controllers. And then I've created it, and what that'll do is that will go through recursively, not recursively, it'll go through the data structure and create all of those elements, add them to the appropriate sizers, take those, add those to their sizers, and so on. It's just repetitive, and so it stamps out your entire UI. Well, stamping out the UI happens on that set sizer and fit function. The actual sort of, you can almost think of it as all of that stuff about the top level sizers, it's sort of setting everything up until create and add is called, and then that top level sizer fits everything into the larger frame. We can do a little bit of cleanup here. I don't need to be redundant, so we can have that sort of convention we have, which if one of these things wants to be specialized, like the upper sizer wants to be expanded and the lower sizer doesn't care, you can add specialization that way. So could we reduce these two statements into one? And I think we can. I'm just going to expose the set sizer and fit wasn't a free function. It was a member function. It's using the this pointer. So I think if we just add another function called fit, we could rewrite everything into one sort of expression. And here we go. So we can see there we end up, which is I have my vertical sizer. It contains the data structure. When I call fit to, what that does is essentially goes through, creates all the widgets, adds them to the appropriate sizers, fits it to the frame all at once. So, and to recap, this is where we started off with. Like that's how we got to it. And so it's like on that sort of left-hand side, I can't really see the data structure, but on the right-hand side, it's very clear what the code is doing. So let's look at how flexible this solution is. So, as a library writer, you start off with something, you're like, hey, if anybody wants to, make this more flexible, how hard is it? Because I did this with some example code, and maybe this is like, falls apart when you have larger types of objects. So my widget, like we were dealing with text, we were dealing with buttons, we were dealing with text controllers. But when you actually look at the API in wxWidgets for the text controller, I was only passing in the parent, the ID, and string, and there's a whole lot of other arguments that it has. It has widgets. These controllers can have their particular offset and size. You can make them bigger and smaller. And how would I pass those to my framework? And so I want to be able to allow this customization to occur here for elements and controllers that want to be customized. I could add all of these like just simply by doing that, and I'll just have more members in my state, no problem. But now my constructor becomes really kind of complicated. What if I don't want to specialize the size, or I do want to specialize the style? So this becomes a little bit harder to do, and what do you do here? Well, I mean, I think we all know if I have a class or a struct and I have some member values and I want to change them, you just use accessors. Like, just how about like a setter? So let's add a setter here. So I'll call it with flags. So if I construct something and I want its flags to be slightly different, I would just use flags with flags. There, now it's different. This won't compile. Anyone want to take a guess as to why this won't compile? The flags returns void. Void actually is not create addable. So it's like a constraint was found. Also, it's probably going to yes, the compiler is going to really yell at me like, with flags, it's returning void. Void can't be used in this context. So what we should do is we should return the this pointer, like this way. What would we call this pattern? People seen this before? Builder pattern. I've heard of Fluent Builder. I think it's technically in the grain for Fluent Builder pattern. I've actually also called this method chaining a lot. I think it's maybe because I did a lot of work in Objective-C with a lot of methods. So method chaining. So the idea being is if you're modifying the state of your object, return this pointer so that it allows you to say, I have a button that has exit. I want to have it red. Make it 16-bit width and add some help menus. You can add all of these functionality. You can start chaining them together. And each time you return the same type. So it allows us to, well, now if I do that way, this code compiles. And as long as I'm here, oh, right, now I can actually, I don't have any need for that constructor to take in that member anymore. So I can make things a lot simpler. And I could add any number of builders to the methods to this. So with flags, with position, with all the various things. So yeah, cool, cool, cool. All right, so as often happens, maybe your requirements for your UI has changed. Your designers have come back and they said, you know what we really want is we want a slider. I'm like, okay, cool, yeah, looks nice, cool. I don't know why, this is a very, very strange UI, but you want to put a slider in there, so no problem. As we saw, what I would do is I would, on my top part where I'm creating my controllers, I would declare that I have another slider, and then I would just add it to my top level sizer in there, so it's added vertically. So cool, so no problem. Let's just add a slider, and we'll say using a slider, and yeah, that should work. Just add another one to my list of usings, and oh, no, it does not like that at all. So I did cheat a little bit with my example slide, as one does. You'll note that by a strange and happy accident, all of my controllers were isomorphic. They actually all have the same API. They all look the same. They take strings, they have size, they have points, but slider doesn't, which actually makes sense. Slider doesn't have any text. It really just has values that it uses. So when I tried to instantiate that in my create and controller, it failed because it's like, I can't put those arguments where you expect. In fact, actually, if I think about it, if I want to make a fully extensible framework that could be used in lieu of wxWidgets, a library, I have to support all of these controllers. And so that becomes a lot more complicated. So I don't, what do we do here? Well, let's examine where we've been actually calling create and add. So this is my create and add function. It does two things. It is controlling the what I want to create, and then it's doing how to add. So it's actually doing two particular things. It's got, what it has is it has the, what I usually think of it as, it's the what to do versus the when to do it. What do you reach for when you need to separate the what to do from the when to do? It's a common design pattern from Gang of Four. Anybody? The template method, not to be confused with templates. But this is the idea being with the template method is I have the template of what I want to do. So in my base class, I will have my algorithm written in terms of a number of helper functions. And then in my subclasses, they can specialize those helper functions. So it allows me to separate the what I want to have happen, which is what my subclasses are for, from the when I want it to happen, which is what my base class is doing. So let's take that and run with it. So here is my widgets. It's got that new wxWidget there. And what I'm going to do is I'm going to have a create function. That is going to be what I want it to do. And that's my helper function. And now my create and add function in my base class will be written in terms of my helper function. So my create and add here is my template method, and my helper method is my create. So now for my string struct, what I need to do is I am going to, where did you go? Oh, there you are. So what my struct is going to do is it's going to contain all of the necessary items for knowing it's a text, basically sending everything along to the base, to the superclass. And then it is going to implement the helper method. So when that gets called, it's going to call wx static text. And so as we were saying, the how to add is controlled by the base class. The what to add and what to create is controlled by the subclass. Okay, cool. Let me put all this together. And when I write that all out, oh, I still get a compiler error. And I'm going to help us all and highlight this is specifically what the compiler's complaining about now, which is target details wxWidget. Widget is an abstract class. Widget is an abstract class. What? Okay, so the problem is not really obvious, but from the code, I'm like, I didn't see anything on that left-hand side that would be a problem. This function's now failing. Let's go take a look back at our builder methods. Now, our builder methods were all turning widget. Yeah, that's a widget, that's a widget, that's a widget. But I explicitly made widget an abstract base class. So I'm telling the compiler, hey, give me a widget. And the compiler's like, I can't give you a widget. Now, if I was dealing with a text controller, I don't want it to return a widget. I would want it to turn a text controller. And if I'm dealing a button, I would want the return type to be a button. So what I really want is I want the type to be dependent on what I'm using. I want the type to be a parameter. And now what we had said at the very beginning is whenever you want your type to be a parameter, you reach for templates. So instead of widget, I'm going to make widget take in a template, W, and I'm going to pass in the button as my template parameter here. And so that way, when it gets returned, it's going to return the widget type. And so it is really it's really mind-bending when you start actually employing this in your code, because it's not often I've just declared a type that I'm now going to inherit from a template version of that type. That's really, really curious. Yes. Now that I've done that, I can start really making this hierarchy very apparent. So I've got now a hierarchy. I can remove details from my base class that are specific to my subclasses, like string is a detail of text controller and buttons, and so I can start moving those details out of my base class. And so where were we? Right, we were going to add our slider to this, so now I've got my slider widget. Oh, we never really settled on what to make the arguments on this for. Let's go back and take a look at that API again for the widget, the slider widget. And I think this is I don't like that. Like, if you take a look at the arguments here, I was thinking that slider, you would specify, I don't know, maybe the minimum, the maximum, and then the value. but apparently the API designers, they determined like, hey, value, min, and max would be the ones that you would go with. And like, that feels like pretty easy to screw up. It's like, in fact, actually, I had someone who would be like, I'd never let this pass code review to have 3 argument types at the same time. It's worse. Because wx window ID is in fact an int too, so this is actually 4 integers in a row, pretty easy to screw up. So I think we can do a little bit better, and that's, I think, an interesting part of writing your own libraries. You can actually improve the code that you're dealing with. So in this case, let's add a little bit of an improvement here. What I would write is, let's guide the user to do the right thing. So let's make it where slider, given just a pair of numbers will be the range, and I will have the convention that will take the minimum if it's not supplied for the default value. And then this way, everything is nicely type safe. You can't screw it up. Right, so that's what my complete slider implementation would look like. And now when I add that, voila. Looks good. And that's our final sort of product here. We have an extensible declarative UI built on wxWidgets. When we take a look at it, it really wasn't all that much code. It's about 230 lines of code. And a lot of that was really just like the way I chose to do formatting with a lot of like lines that were there. And some using declarations. And so yeah, I'll say, if you then examine this code with where we started for our toy example, it's pretty striking about how much more readable the right-hand side is. I think when I come down to it, combining the controllers and the layout, it makes it so much easier to see what the intent is of the code. Like I can almost intuit what the UI is going to look like just by looking at the right-hand side. It's really almost impossible to forget to add a controller to the layout. If I have a controller inside my struct, it's going to be in the layout somewhere. It's not going to be put in the wrong place. I can't really add it to the wrong sizer. It's going to be in the tree structure. I can really see where it's going to be in that tree structure. It's very dry. We took a lot of pains to not repeat ourselves. We had that convention of if you want to specialize the sizers, you pass them at the top level, so I don't have to keep using that sort of sizer flags all over. We have a convention, like a hierarchical convention that we added. And one of the things that actually is really interesting about this is when you look at that right-hand side, there's very little wxWidgets there. So in fact, actually, all of the work is done by that fit-to function. In theory, I could write another adapter for fit-to, and I could make this work with Qt. GUI. I could make it work with Juice. I could make it work with curses. And so that's like one of these kind of remarkable things. It's like, hey, this UI, this declarative UI doesn't actually work with it can work with everything.
Did you do it?
I'm nerd sniping. So, lessons to take away. Look for data structures hidden in your code. They're there. It may not be apparent. You'll be like, I can't find anything here. But do some refactoring. You'll start saying, hey, there's some common things I'm doing here all the time. Hey, that's a data structure. Reduce the number of statements, favor expressions. Watch Ben Dean's talk. Just watch all his talks. Maybe that's my hidden point here. But yeah, so you really want to favor expressions. You have a lot more, the compiler understands them more. You'll understand them more. Be familiar with your gang of 4 patterns. Like the builder pattern allows composition. The template pattern allows you to have flexibility and allow customization. It allows you to set things forward in motion. I've actually, if you're interested, wxUI is the larger UI framework where I've gone further with this. It's a fun little library. I've used it for my projects and built up a number of different UI elements on top of it. It allows the customization points. I go into a lot more details on how it works in some other in the readmes there. And I think that's all my slides. Thank you. So we have time for questions.
Thanks. Absolutely great talk. The one thing I was missing in your slides was error handling. So I'm wondering, does all of this require exceptions, or is there any other way to?
Yeah, I think when it comes to a lot of the UI framework, so I'm like, as I said, I leaned into the UI framework, and with that, it's WX would, they have their own exceptions. They'll throw things when they're constructing UIs, memory out of memory, invalid sort of typing. So if you do little things like I want to have a style like to expand the text, but you haven't actually set up the left-right sort of thing, or the correct sizers, there'll be exceptions are thrown. And I just don't have any type checking beyond exceptions. I just use exceptions there.
It's basically not quite usable in code bases that refrain from using exceptions.
I don't think you would use wxWidgets in non. like I think if you're using a GUI, you're probably already at the higher level that's using exceptions.
I think he means the general style.
Yeah,
Oh, the style.
I'm not even referring to UI.
Oh, yeah. This just leans into what wxWidgets would use, and I'm leaning into exceptions on that. So yeah. Could you build something? I think what you can do, there's no reason you couldn't build that in there. Like a lot of times so I do a lot of compile time checking to make sure I'm not constructing things incorrectly. And then actually, as they're constructed, I could, since there are a lot of constructions, yeah, it might be challenging.
You could probably pass up a chain of expected and then have
a chain of expected would be the way to do.
Thing propagate up.
Yeah.
Perhaps also some callbacks.
Probably not.
Yeah. I mean, that. All right. Thanks.
So, thank you for the talk. You made wxWidgets sizer code beautiful, which I didn't think was possible, and that's awesome. If I wanted to use your library and then be able to access the controls later, is that possible?
Yes.
Okay.
Yes. I've actually there's a part 2 and a part 3 of this talk, the technique that I looked at using was, I'm not exactly satisfied with it, but the idea being is I almost have I call it a proxy. It's like a smart pointer type of object, which is what you can do is you can say, okay, I want this proxy object to be equal to this within my sort of declarative UI part. And what happens is that becomes something you can dereference later. So if you have it in your upper level class where you're like, I want this controller, you can have a way to access it later. It's a little fraught because it becomes like a smart pointer, as in it could be it could be there, it could be not, depending on if it's been allocated correctly. So I'm not satisfied with that. I've also tried to make it so that anything you can do so you don't have to touch it. Like there's other ways to do it. wxWidgets has that convention, which is you can go into the object and you say, find the particular token I'm interested in with the ID. So I give you the ability to specify the ID, and then binding functionality later. We didn't get to it, but you can bind functionality so you don't actually have to get it back. So yeah, there's 3 ways. You can find it, you can add functionality, and I ultimately have what I call a proxy object, which allows you to get the actual object when it's constructed.
Cool. Thank you so much.
Yeah.
Thank you for the talk. Yeah, it was a great tour de force in kind of deductive API design. I'm very curious about how you deal with change, right? Because the UI is not like a static tree; it's like a function over time, right? Like you're representing something that is changing over time. And I'm very curious what the solution in your API is for that.
Yeah, I think that would be like if I'm modifying the UI and I'm sort of saying, hey, here's the layout was before, now relay things out. The way I would approach it, and the way I have approached it, is I have actually like subroutines that return that entire structure, that data structure. And then it's an interesting thing to consider is because now all of these data structures, they actually, going back a couple slides here, an interesting thing to consider is no code really gets executed until you call that fit2 function. Really just it's just a static data structure that's there in memory. So actually you could create any number of data structures and just have them be returned by a function called fit2. And at that point, the runtime framework will deallocate all the old controllers and put new controllers in place and relay things out. So the way I would handle change is I essentially would, I just have multiple versions of this and then do that. In fact, actually, you could have elements be composed together. I could have that middle part, like maybe that row, I want to just change that row. Well, I would break this into 3 functions, like get top row, get bottom row, and then put them together. And I would just have these, I would replace the hsizer with the button and text controller with a function that returns that object. And depending on some runtime code, could return another one. So if I needed to change it, I would just call this and it would relay things out.
So if let's say like that string dog, right, it's coming from a property in my data model, right? I will have something that is observing my data model externally.
Oh.
And like recalling this code.
That one I would actually, if I'm just changing one of the values within the controller, I would bind that to a controller or I would change its value. If I wanted to relay out my controller, I would use a different sort of, I would just like relay things out. Right. Yeah. So
thank you very much.
Yeah.
I feel like this question's already been answered by the other questions, but I'll still ask it. Would you consider making those members R value qualified, R value reference qualified, to force your user to use this? Do you see what I'm trying to say? So you were going to try to force the user to use your API how you intended it to be used. Therefore, R value reference qualify all those members, so they have to use it on temporaries. They're not allowed to name these things. I mean, they could.
They could.
They could. Yeah, it would take more work.
The Fluent functions are returning L values Fs.
Yeah, but they could return R values. You could swap it around.
Yeah.
Well, yeah, but that's how he designed it to be used. I'm just asking, right? Like, would you consider it? And see, I made him think. That's good enough. I'm going to sit down.
I think where I think my code, I support both, like L values and R values as the optimization to forward them in place. I don't think I force that because I don't see the value in forcing it. I guess where it's like, why force the function?
You can make your API, force them to use it how you thought they should.
Okay, that's a good question. I'll think about that.
There's another option, which is to use deducing this and take the this by value.
Right.
And move through.
And that would make a copy, but or it would move it, and it would yeah. I have to rewrite all of my wxWidgets in terms of deducing this to at least reduce the complexity, because I have, when I'm returning with the builder pattern, I need to use the right one for R values and L values. But I haven't thought about constraining it so it has to conform to this style.
Okay, good.
Yeah.
Think about it later, that's all.
Awesome. Well, since there's no other questions, thank you all so much for attending.